everybody here. So let's just get going. So what I'll try. Any of you in Robert's class? Okay, that's good. So you get to look at it live. But I will also I'm also recording it, so I'll load it up immediately after the lecture, so that the others can actually get it as well. Now, first of all, I just want to say that you guys did really well on assignment two. We got much better results, I think, this year than we did last year. So I think that on that front, it's worked really well. So what happens is we started as per my announcement from last week. We've started on assignment three. So we've got basically 4 more weeks, including this week, of consultation time for assignment three. Don't forget that I'm also available to talk to you guys outside of studio time. Of course, come to studio, talk to your tutors, and if you need any additional help, or you want to chat about your work, please get in touch with me. Obviously, my office hours is preferred, but I'm happy to consider any time to see you guys outside of that. If I'm free, certainly I'll do so. So what we'll do for assignment three is that I'll go through a few bits and pieces today, really about the idea of assignment three, and then how to proceed, how we might actually deal with assignment three, and then we will work on it in class, and also I'll put up more information on this during the week, or in the coming time. So I'd just like to say, first of all, that this assignment is calibrated to the time frame. Okay, so what we do is it's shorter than what it was last year by 1 week. In terms of from this lecture onwards, I mean, we've got the same time if you started last week, but the thing is that we will organize the outputs, if you like, so that it suits the amount of time that we've got left. Okay, so you won't be required to do the same number of drawings as the equivalent class did last year. It will be a slightly less based on that, based on the fact that it's a slightly shorter time. Okay, so assignment three brings together assignments one and two. So the way, I think I've spoken about this before, the way we've designed this unit is really so that you can come to terms with the site and the program, or the functions, and then you can freely go and explore some ideas without having to consider the brief or the site. Some of you have chosen to do that anyway, so that's fine. But really, the whole idea was to have that, to be exploring this free of that part. And then really assignment three is to bring that together. So essentially to apply your conceptual ideas that you've explored in the models to the brief and the site. Okay, so petrol stations are now a very common architectural type that we all use. And it is a unique type, I suppose, in that firstly, it's really a 20th century type. So it didn't really exist in the 19th century because there were no cars. There weren't enough cars at that time. And it is also a unique type because it's designed completely around the car, being something that, of course, is about servicing the car. Nowadays, it's run by large corporations, so branding is an issue, and also a corporate identity. But what you can see in terms of the structure of these things is that they are really very, very similar across brands. So everything about them is standardized for economy, repeatability, ease of construction, and familiarity of use. Okay, so this idea would have been an interesting idea as it was developing, but the reality of it is that this kind of architecture has not really developed over the last 20 or 30 years, because they've kind of perfected the system, I guess. Now, the system is a economic and a commercial system. which is systematized for maximum profit, if you like. Okay, so a few of the problems of this kind of approach is that it doesn't respond to location, site, place, or time, and it's really no longer about architecture. It's really just about construction and building and economics. So what you can see here is that really what they try to do is to flatten everything, because once everything is flat, then they can put in the minimal amount of structure and to provide the services that they provide. Okay, so there's the reason for all of this is really not architectural. It's really about a system. I admit there's a certain elegance to this, but you know what we're here to is to actually explore what the architectural possibilities of this type are. So this lecture is about how we might use the work from the first two assignments in assignment 3. And let's start by looking at the evolution of service station architecture. So what I'm looking for here is what the starting point for the architecture was as a way of for you guys to think about how you might start or how you might continue with assignment 3. And in this, we'll try and look at the equivalence of what was in assignment 1 and assignment 2 as well, in terms of the brief and the concepts. So what we see here is a couple of examples, the top one from 1921 and the bottom one from 1927. So in the early days, service stations were really the architecture of service stations adapted existing buildings. There's plenty of seats here in the middle here, so come and sit in the middle here, if you could. I don't mind. Come on, come and sit in the middle here. So what you can see with these two images is essentially they've added the Bowsers to the front of these existing buildings, or maybe the buildings were purpose-built for the petrol station, but they were other kinds of buildings that were adapted to the use. What we can see here is that it's relatively flat, and we can tell it's a petrol station by the Bowsers and also by the signage on the buildings. So by the time we get to the 1930s, and we start to see purpose-built petrol stations, and these purpose-built petrol stations start to use the architecture of the day. Yeah, the approaches that people were taking to build all sorts of buildings. So they're then adapting that kind of architecture to the petrol station. On the left, we see the Gilmore petrol station from 1940. On the right, we see a Mexican-style Southern California petrol station from 1933. So, interestingly, you can also see the beginnings of Bowser technology. You see they've got 3 different fuel pumps here, and each of those fuel pumps had a different kind of fuel in it. So nowadays what we have is we just have one with 4 different nozzles attached to it. But in those days they actually had 3. So we wouldn't do this nowadays purely because what happens is that we only have 3 Bowsers. We have 1 Bowser per car, but we have different types of fuel at each one. You can also see that everything is they hadn't quite worked out their dimensions yet, so everything is really quite tight. There's seats in the front here, everybody, so come up and have a seat in the front. And there's seats in the middle, so come up and sit in the middle. So that's one thing, is the gaps of the aisle, you can see are not very big, but that may well be related to the size of the structural members that they had available to them at that time. So around the same time, you started to get architects such as Arne Jacobsen. This is one that's from 1936, who was specifically trying to design buildings according to function. Yeah, what you might call a functionalist approach to architecture. So in this case, what they did was they actually looked at what needed to be provided, and then they applied their particular approach to architecture to suit that need. Okay, so really, you might say that while the Art Deco and the eclectic or revival styles were doing the same thing, really, I think the difference with Functionalism is that they very much looked at what was required before deciding what it needed to look like. I mean, this was their approach to architecture very much suited this because it was really about the new, about machines, something that was undecorated and about function. Now, nowadays we know that this is actually a very specific aesthetic approach, and it wasn't very objective in terms of function, and it still had a particular I suppose artistic bent to it, but it just happened to look very clean. So what we can see here is that we start to see that we've got bigger spaces, bigger spans. We've got coverage between the Bowser and where you pay for it. It's still very flat. It's tiled as a way of keeping everything clean because you've got a kind of dirty trade, if you like. And it's actually trying to come up with an architecture for the car. But what it's also trying to come up with is to test the limits of the technology they had in those days. So everything was actually about making things really light. Yeah, so you can see here with this roof, it's really, really thin. There's no visible structure, and then there's only one column that's actually holding it up. The whole thing is painted, so you can't even really tell what the material is. Yeah, so that was one of those things. Was about abstraction of architecture to represent a kind of universalness, or to take away from the sense of materials, if you like. Certainly in Jacobsen's case. So in this case, also you can see a contrast between the blocky, I suppose you could say the heavy, and the planar or the light over here. So compositionally, they were starting to do things that we were exploring in our conceptual studies. You can also see here that they've got modern Bowsers. So this thing has been adapted to contemporary technology. If we look at another example here, this one called the Autopels, which was a service station for Texaco in Nijmegen in the Netherlands of 1936. Very much this is also part of that architecture, a modern architecture that was about pushing the limits of structure. So you can see that they've got this big roof here that is a cantilever, and there's the paradox here because this thing is obviously some sort of this thing obviously has weight, but you can see that it's actually sitting on a glass room with no visible sense of support to it. So this was continuing on the idea of structural gymnastics to really push the paradox of structure and of form, and was very much something that these architects, the style architects, were interested in at that time in the Netherlands. Other approaches to the machine came from the futurist architects, who were very revolutionary in the sense that they were specifically trying to design buildings for the modern age, for modern infrastructure, trains, planes, and automobiles. And they were very much about how to try and get dynamic, the idea of the dynamic into architecture, try to get try to consider buildings from the point of view of the machine. So in this one, this is a petrol station that we can see in Eritrea in Africa, and designed by Giuseppe Petazzi and completed in 1938. And you can see that there's two wings here, two huge cantilevers in balance, and then with the central elements here. So this is very much trying to draw from the aesthetic or the architecture of aircraft as a way of providing a different function. So it's looking at that kind of cross pollination, if you like. So very much the idea of balance, trying to push the idea of cantilevers and that kind of amazing, or that ability to pull off a cantilever with no visible structure from below. Of course, from above we can see these huge beams that are actually supporting this beast on the bottom here. Then you have this idea about lightness, which you saw in the Jacobson example a few slides ago, and also in this example, which was talked about by Gevorg in his lecture a few weeks ago. So really, what we have here is an effort to try and put forth a paradoxical idea. So something that's very solid and very heavy that's actually floating. So you can see that this is one piece or one layer that's kind of folded into it, and it goes up here. So what you can actually do is you can go up here and actually knock on it to see what material it is, and then the same material is then cantilevered over. Okay, we don't know what this material is, but I suspect that it is concrete. Yeah, I suspect that it is concrete. So here we get the idea of something heavy that is doing something that it shouldn't be doing, so to speak. And in a way, they were kind of showing off what they could do. And what we saw in Simon 2 is also some of the models exploring this idea of balance of the cantilever, and really taking it to the next level to see how the two things balance themselves out. So how things are anchored in, and how things are really in a kind of precarious balance. Things that look like they shouldn't be standing up actually do stand up. You can see with this one, it's actually overhanging here. The point of balance is here. So without this weight here in that precise location, the whole thing will either fall forward, or if the weight was put too far back, then the thing will fall backwards. And with this one here, this is actually something heavy that's holding onto something light, and can work in two ways. So it can actually work as hanging over an edge, or actually holding something up like this. Now, so moving right along, we also had started to see examples of petrol station architecture or service station architecture that started to deal with suspended things. So really looking more at the relationship between things that were in compression, this arch here, and things that were in tension, which are these cables, and really trying harder and harder to make these things seem really light by suspending them. So it's a kind of precarious relationship where it doesn't really look very stable, and yet there it is. And then that is then anchored by the box. The box is always there because we need somewhere to go and buy our milk and pay for petrol and what have you. Okay, so the idea of precariousness. And then we had a few models also which looked at that, which was very much the idea of tension, which is held by the little cables. This one is so successful you can't even see the cables, and neither in this one. Probably more my crap photography, but never mind. Really, so you have these very light things holding these heavier things up, so that so that you're actually playing around with that idea of heavy and light in that way. We also had started to have explorations of how the shape of things actually contributed to the structure. So this one, a 1949 example by Aldo Favini, where the roof was actually reinforced concrete and held up by a piece of steel. So you've got the thing here where you've got this really fine steel structure holding up this thing, which is really like stone, so notionally very heavy, and the fact that it manages to hold itself up like that has got to do with its particular shape. Yeah, so the particular shape also ends up with allows the concrete itself to be quite thin, and you end up with very thin edges to exaggerate that idea of a plane. This is another example. Hyperbolic paraboloid structure. So although it is concrete, it's the shape of this thing going this way, which actually allows it to be structural and to stand up by itself, right? You can see it's quite a thin thing, tapering down to something thicker at certain parts. So you can see that actually there's not a lot of material there. So again, there's this kind of showing off of materials, of something heavy that is actually being held up just by its shape. So the way that this got articulated in models was really, I think, from these two. So you've got a very clear demonstration of a heavy thing, the stone and the brick, the stone on the left and the brick on the right, and being held up by very light things in that case. So you've got the paper on the right, which was really quite floppy when they didn't have the brick sitting on it, yet it's holding up the brick, and then the aluminium mesh on the left, which is quite a soft material and really held up by its shape. So really what happened is that petrol station architecture started to get, was very adventurous, as we can see, right up until the 60s. This example here was designed in the late 60s. But what you also start to find is that these big petrol companies start to standardize everything. Yeah, they start to standardize everything, and through the process of rebranding, of constantly changing what the way that they look, they manage to slowly, I suppose, wash away all the interesting architecture that we were getting. This is probably the last example of an interesting approach, which is really your kind of steel mushrooms. Again, that idea of balance, everything being held up on just this single post, these kinds of umbrellas or mushrooms, if you like, which are overlapping to provide coverage. And this design, this particular one is in the UK, but it was designed in the late 60s and then rolled out across the US and Canada and also in Australia. Although, and there used to be actually a mobile that was on the corner of Glenferrie and Glenferrie Road and Barkers Road in Kew in Melbourne, close by to where I used to live. But I noticed that it's been demolished now and replaced with a generic box from the first slide. So what we can see is this kind of big period of experimentation before everything got really boring again. But that's not to say that there are no interesting approaches to service station architecture. So what we are going to look at now is what more recent examples are doing, and perhaps how it can inform us as to what we might like to be doing. So what I want you guys to think about is really how to make the existing petrol station better in terms of its architecture, yeah, and really to as a way of as a commentary on the current state of corporatized, boring petrol stations that are not driven by architecture. Okay, they're fine for what they are. We all use them, and we're all quite happy with using them. But we have to put on our other hat, which is as architects, to actually see where all these things can go. So the first example I'll look at here is really a servo in Slovakia, which is in Europe, from 2011 by Atelier SAD or Atelier SAD, which is what you see is a very light object, light because in the context of night, what it's got is the way that it's lit up makes the thing look light as in light and dark, but also light as in light and heavy. And it's got this really thin edge, which is accentuated by this light, which again promotes the idea of lightness from a certain view. So what's interesting here then is you've got this very heavy material that is trying to look very light and trying to be light by having minimal supports, and of course using its shape to be structural. So you've got the surface of the roof part articulating into the surface of into the column itself, and that's contrasted against this material here, which is timber. So it is a light material which is then made in a very solid form. Okay. The interesting thing about this building is that it does have a different look during the day. So during the day, you still get that kind of those light proportions with the thin edge and what have you, but you start to be able to consider the concrete much more as concrete. Then there's that paradox again. Concrete is supposed to be a massive material, so how can they get it so thin? Yeah. So how does one actually take this idea of light and heavy and light, and actually push it to another level? You can see here that despite the fact that it's got this circular form here, it looks like a bit like a Fitbit. That's not a Fitbit. One of those a fidget spinner. Looks a bit like a fidget spinner. But you can see that the way that the circulation goes is still very conventional, going straight through this way. When one gets up close to the thing, one can really see. Once one can feel and touch and see close up these things. These things are clearly concrete. So once it's close, then you really get a full sense of the material. When you can touch it, you can hit it with your hand, and then you can the realization that the thing that looks so light as you're driving in is really something that's quite solid. So the next approach here draws on really this idea of structural shapes, and if we look at this example here, which is the Pops Arcadia service station and diner on Route 66, which goes through Oklahoma in the US, by Elliott and Associates. And I'll put the slides up so you guys can get all the details and go and look them up just to see if you want more information. This one is also something where you've got this huge cantilever here, so it's a bit hard to tell. But really what we have is the relationship between this very light structure with the trusses, which are visible, and this heavy brick box here, which actually is some sort of interplay between the two, I guess. And you can see a different image of it here. So obviously it's got this sign here, which tells you that it sells soft drink. But also it's a petrol station. So you can see that these brick things here are kind of used as anchors, although the structure also anchors into the ground. And what we can also see here is a very particular approach to laying out the site in terms of landscape. So there's views out this way. The car park itself makes a view, and then this thing is designed to be seen from the road, I suppose. If we look at the next slide, we can get the full frontage, if you like, or of what that structural showing off is. This is really quite a large cantilever, and you can see that the aisles are quite big. So each of those aisles have space for a car on either side, and then looks like it has space also for a car to pass in between. So those kinds of things are fairly well sorted out nowadays. When we go back to those ones in the 1930s, there was only space for one car. Convenience wasn't big on their radar. It was really more about what they thought it should be, and what they thought it should be was not to make it easy for people. Don't forget that at this time people also had drivers. So pumping petrol was something that that your staff or your workers did, not that one did themselves with, and that's because cars were expensive and not available to everybody, whereas nowadays everything has changed. We can see from this slide here that the way that the car park is laid out and the way that the landscape is configured for this servo is very much part of the layout of the servo. If I go back to to the slide before, you can see that this pathway comes around here, and everything is considered in the same design to service the petrol station and restaurant that's in there. So this, I guess, looks fairly conventional, even though it's achieving quite amazing distances. So really, I suppose this then is an interesting example. This is a fuel station. It's a petrol station and McDonald's restaurant in the city of Batumi in Georgia, which is in Central Asia, by Kamaladze Architects. And what's interesting about this is that when you're looking at it, it's just this shell that's cantilevered over the petrol bowsers to actually provide shelter. And what's interesting about it is it's kind of dematerialized in the sense that you can't really tell what is holding it up. This material is a lightweight material. You can tell by going up there and knocking on it, and you can see anyway that it is a cladding that's in flat planes that are laid out in triangles, which means that it is some sort of lightweight cladding to whatever is holding it up. Is holding it up on the other side. You can see also here that they've actually worked quite carefully with the way that they've got the circulation going, so that there's a curb here, so that you don't get too close to this bit here, don't drive into it and then damage it. Yeah. If we look at the other side of this thing, we can see the petrol bowsers here, and this is that big cantilever. Then what we see here is there's this glass dome, if you like, dome-like structure, which is actually connected to this big cantilever. So it appears almost like this very lightweight thing is creating this view here. You can see the McDonald's sign there. You can enter McDonald's from the back, but also from the front. And when you're inside the McDonald's, what happens is that just to further confuse you, is that on the inside of this surface here is this. So you've got this earthen plinth, if you like, which is then forms the view for the outside dining area for the McDonald's. So then you get this interesting thing where the building itself is creating views within the building, in addition to the views outside of the building. Okay, so a lot of buildings are actually about looking out, especially when there's something to look at. But this one is about looking in as well as looking out. And if we look at its context, perhaps we can tell what's going on here. So this is that kind of grassy mound in the outdoor area here. And you can see it's a new area that's being redeveloped, so it's really quite messy out there. And it's really quite messy, and so they're trying to create a different environment inside. What you can also see from this is that the shape of the building is also something that is affecting the circulation of the thing, and there's separate circulation with the car parking for the McDonald's on the back, and then extra car parking on the side here. And you can see here very much that they're trying to create an environment for the users of the petrol station, and very much that what's around it is actually also designed for certain architectural ends. You can see here that different to the everyday generic petrol stations where they just put down this huge concrete platform, that the platform here is really cut back to just what it needs, and the rest of it is given over to something else. In this case, a water feature, which apart from giving a more pleasant area to dwell in, it seems like this kind of little retaining wall is about seat height. So this kind of then becomes a bit of a public space, a bit of grass and so on and so forth. So not maximizing every single square inch for ease of construction, but actually thinking about the people who might use it, and not only the people who might use the petrol station and the McDonald's, but also the people who might just be walking by. Now, just as a reminder, this one did remind me of these two models here. You know, the sort of the frighteningness of the big cantilever, and not being able to tell how it stands up, although everything slowly gets revealed as one engages with the building. Next project we look at here is and there's not many more to go, but the next project we look at here is the Houten service station in the Netherlands by Salmon and Partners of 1999. And if we're looking at how this project here was starting to control the circulation, this project here is controlling it in a much more active way. It's a much more active way. When I read about this project, apparently the reason for the screens is that it's located in a really windy location, very flat, very windy location in the Netherlands. And I don't know whether any of you have been, but it is bloody windy, and in winter it's bloody cold. So anything that's going to take out that wind is going to be a good thing. So what the architects have done here is that they've got these screens filled with mesh, which are to actually slow down the wind, so that as you're outside pumping petrol, you don't actually, it mitigates the effect of the cold wind. What's interesting though is that they've chosen to have a series of these screens which then actually control how one drives into and drives out of the petrol station. Yeah, so this is again looking at the potential of how circulation can actually make can actually contribute to an architecture in a very direct way. Yeah, so again the idea that the realization that we don't actually need to we don't actually need all of that concrete that we see in generic petrol stations. And I suppose there were a couple of models that actually looked at this, which were actually about pathways. So for those of you who looked at pathways, that's certainly something that you can bring to your consideration of the petrol station as well. I mean, these two are interesting because all the pathway controls we've seen in the last two projects, in the last two petrol stations, are flat. So what these models suggest is that we're starting to look at pathways which are separated. Okay, pathways which go up and pathways which come down. So this really, I suppose, questions the idea of why a petrol station needs to be absolutely flat. Here we see a 2009 petrol station in Los Angeles by Canna Architects. And this one is an interesting project. It has many things that we saw from the ones before. So it's got this big curved roof, big heavy looking roof that's held up by these spindly little legs. Again, you've got the geometry of the roof, which provides cover for its users to get into the restaurant and to pay for your petrol, but the circulation is still very conventional in this one. What's interesting here, though, is that they've got a car wash on the end here, and you access the car wash by actually going up this ramp and across the back, and then back down to the car wash. And then while you're on the ramp, you actually get a view onto this garden over here. So just to explain that a bit better, you drive up here, and then you can see the start of the ramp there. You drive up there, and then you actually come down to the car wash there. So that is a way for the petrol station to actually queue the people who are wanting to get their car wash, and giving them something to do in the meantime, which is actually negotiating the ramp. And then while they're on that ramp there, you can see that they then look out onto this park over here. Remember, we're in America, so you're driving on the left side of the car. So basically, you're closest to the balustrade here, and you're then looking over this park here. So you can see from this drawing here that what happens is that the geometries for the Bowsers are pretty rectilinear. You drive in, and then you pay, and then you can go out this way. Actually, is that right? Oh yes. So you're on the other side of the road. You come along here and you turn right into here. So righty tighty, lefty loosely in America when you're driving in America. So their right turn is like our left turn. So you come in here and then you go out here, or you go into the car wash. The ramp goes up. You can see this indicates going up. You go over some rooms that are underneath, and then you come down into there. And while you're on the ramp, because there may be a lot of people queued up, you get to actually look at this park, which was actually designed as part of this particular petrol station. So I think that's a very interesting thing, especially for our site where we've got such a strong landscape that's just beyond our site as a view. So what we should be looking here is how do we actually mediate between our very unlandscape type function with the landscape beyond. And the landscape beyond is man-made in terms of the agricultural land, and also natural, which is the hills that are behind. So we've got this thing from the pinnacle of man-madedness, if you like, the car and petrol, which slowly goes back to the mountains or nature behind. Just another slide as to how that works in terms of the drawing. So you can see that you go up here and then go across the back here and then back into it. The other interesting thing about this site is really that although they have flattened the part where the petrol station is, it does look like there's quite a bit of shape in the actual site itself. So for us, our site has got quite a drop from the road. So I'm happy for you guys to be filling it up so it's relatively flat, but I'm also happy for you guys to try and work with that topography. Okay, so how do we use the topography for our designs? So now, especially now that I've freed you up from the big concrete platform, it means that you can start looking at interesting ways of doing that in terms of designing an architecture that is more that relates directly to the site in terms of its topography and in terms of its views. And certainly, if you choose to make it all flat, it's fine for you to make it all flat. But then what you guys need to think about is how you treat those edges and how that platform, which will drop away quite a lot to the back and to the sides, how you then deal with those in a kind of landscape form approach. So just as a reminder, what we're doing, the way to start, as in what you should already be doing, as in terms of what my announcement said recently, was that you really want to be testing your concepts against the site and the program as a way of starting. Now, let me just say this: and what I will say here is that the conceptual models were a way to get your mind thinking in a certain way. Those concepts need to be tested against the program in the site. Those concepts may not work with your site. So what you might need to do is to adapt those concepts to the program and to the site. Okay. So really, it's about seeing the potential of it and seeing where that can take you. And we fully expect that what we get in a month is not going to be your model put on top of your conceptual model put on top of a site model. We're going to expect the ideas from that model to be adapted to a service station design that is then adapted into the site itself. We've got an AutoCAD contour map, which I will put on the Moodle this week. So for now, until we get more information about the site, think about just consider the relationship of the building to its circulation on the site, and then we'll figure out in the next stage how to adapt that to the topography, whether it is about filling up the site or whether it is about doing some multi-level sort of thing. Are there any questions? Okay, very good. Let's split into our groups. As per usual, Rob's group will meet Melanie this afternoon. I will load this up onto Moodle right now so that